You're allowed to record now with the basics of how to use the terminal so you guys don't suffer. Okay, my terminal, just a heads up. Actually, let me record first and then we'll do. Okay, for those of you listening online at home in your bedrooms that aren't here because you all suck, we are doing a Python and Bash help session. What I'm going to be going over today is essentially the basics of how to use a terminal and how to use Python, which both of which you'll need to know for 2002. So let's talk about a terminal first. So let me share my desktop. Just a heads up, my terminal is going to look a little different from yours. That's because I have theming and stuff applied to my desktop, but functionally it is the same as when you open up that Ubuntu terminal that you guys are so used to. So I'm going to open up my terminal. Normally you would do that with your menu. I use special key command, so I just hit a key command and it opens up. I'm going to make this a little bigger. Okay, this is the terminal window right here. You'll notice my terminal. Your terminal will probably not look exactly like this. My little arrow here is generally going to be a $sign in a normal terminal, and the little squiggly line there means something, and I'll explain exactly what it means in a second. It is basically what directory I am in. So this is a terminal. This is realistically all you need to interact with a Linux system. You can do everything that you would ever need to do from this location, which is kind of crazy to think about how powerful just this one little program is. So let's talk about how do you get around here, right? So you're probably used to Windows and your file manager where you click around and you are able to navigate through your folder structure and do stuff there. Linux is the same way, except instead of clicking buttons, we use commands. So the first command is where am I and what am I? So first question, where are you? How do we figure out where we are and what is the path to the location we are at? We have a command for that. It's called pwd. You can see here, I type pwd and I get an output. It's /home/argent. So another way to reach where we are is using cd/home/argent, and that is the same place. This place that we're at is a special location in the Linux system. It is called your home directory. And you can kind of tell that because it's at /home/your username. Every user has a home directory. If you were the root user of your system, your home directory would be just / or the root. So basically, every time you make a user on your computer for every Linux system, you'll have a home directory be created, and that's where that user would store all of his files for his things, and for that specific user. So the question is, just like a good way to think about this is the desktop on your Windows system and how you have a different desktop or a different My Document section for each user. Now the question is, how do we know what's in the Linux system or where we are? What's in the folder? Well, we have another command for that. It's called the ls command, and that stands for list. And that what it does is list all of the things in our directory. So if you notice here, I have 4 or 5 different folders that have a bunch of information in them. And we can kind of look at them and say, well, let's explore. So let's say we wanted to explore my workspace. How do you net change folders? So to do that, we use the cd command, which stands for change directory. So in order to change a folder, you do cd space and then the name of the folder you want to go to. So let's say we go check out my workspace because that's where I do all my work. I type in the first 3 letters and then I use my tab complete, which tries to autofill it. So I get cd workspace. I hit enter and now I am in the workspace. You'll notice the little thing on the side of my screen right here has changed. For me, I have that set up to display where I am in my folder structure. So I have with respect to home, or in this case, where am I? That's just an add-on with my terminal that I modified and made look all pretty. But yours will probably have something along those lines, or it'll say I think it says your computer name, your name, and then maybe some directory stuff after. I think that's the default in Ubuntu. That's just some information to help you at a glance get an idea of what's going on. So let's look again at what's here and type ls. And you'll notice you have a bunch of different folders that have all sorts of fun stuff in them that are different projects I'm working on, stuff like that. Now, how do you go back a folder, right? So we now be essentially use this cd workspace. We want to cd into a directory like cd into arjungandhi.com/site/assets, right? You can kind of continually tab complete and add any layers of these slashes to get somewhere. And then if we hit enter, we then navigate to that folder. And if we type pwd again, you'll see we'll get the path to that location where we are. How do you go back? Well, cd has the same functionality. It's called cd, but then instead of typing dot, you type dot dot. cd dot dot will take you up one folder in the directory. So if you type pwd, you can see now we are at one folder higher than where we were. What dot and dot dot really refer to is dot is a reference to the current directory, and dot dot is a reference to the directory one above. This is a standard in all Linux folders. So you can use that to kind of manipulate other things other than cd. So for example, if we were to ls dot dot, we could then list all the things in the folder above, right? So now we would see readme, site, and sync, even though we're already in the site folder. Another really useful command when your terminal gets really busy is the clear command. It will just wipe everything off the screen and you'll be set. Okay, so let's use another fun cd command, which is if you just type cd space and then hit enter, it takes you back to your home directory. So again, if your home directory is your home for your user, or if you're root slash. It's a really useful way to just hop back to your main directory. And that's kind of how you navigate through stuff and make things in touch files and stuff like that. And kind of navigate through the file directory. So you can kind of essentially cd dot dot and view all the various parts of your Linux system and just mess around and be able to navigate through those folders. And while that's super useful, let's go into the directory I have made for this session. So let's go into my temp directory /3002 help. Cool. This is my temp directory. It is a folder I just made. It's where we're going to keep all the files that we're working on for this project. So in this folder, we can now navigate around pretty effectively. It's pretty simple. But how do we change and edit files? So another really useful command we have is the touch command. So the touch command will make an empty file with the file name that you pass in. So we're going to call this hi.txt. Now, if we ls, we'll notice a new file called hi.txt. This essentially allows us to make files in places that we want. How do we delete a file? In Linux, we can use the rm command. Rm is a very powerful command. Do not type it on things randomly. It has very dangerous add-ons that will make it even more scary. So be very careful while you're using the rm command, because it is not like the recycling bin in Windows where you can go back and get the thing you deleted. Once you rm something, it is gone forever. So we're going to rm hi.txt. Now if we ls again, we'll notice it's gone. So the other question is, how do you make folders? We can use the mkdir command, so make directory, and then give it a name. We're going to call this, my first folder. Cool. And we have something called my first folder. We can then cd into my first folder, and then we can make dir or touch another file called hello.py, and we'll make another one called site.py or something, right? So now we have these two files, and if we cd dot dot, we now have my first folder, and if we cd into it, we can see the two files that we've made, hello.py and site.py. Now, the really scary part. What if we wanted to delete the folder and everything inside? This is where the rm-r command comes in. So the rm command generally only removes a single file. The rm-r command recursively removes every file that you pass in. So again, be very careful with what you rm-r. So we're going to rm-r my first folder, and it's going to delete the entire thing. If you're deleting some certain files, like the .git directory in a folder, you're going to have to use the rm-rf, which means do not ask for approval, just go. That's where dangerous stuff happens. I have personally rm-rf'd, or it is the equivalent of like Control-Alt-Delete your like C directory. That joke is in Linux. It's called rm-rf. Do not rm-rf your home directory. I have done it, and it sucks. Because it will recursively go through and delete everything. So that's the warning on deleting files. Be careful. Let me double check that I have everything that I covered. Oh, okay. The other couple things are, let's say we wanted to move a file or rename a file. We can use the mv command. So let's say I have a file in here called python.txt, which covers what I want to teach today, or just like a rough outline for me. So if we move python.txt, and now we can pass it like a new name. So let's say we want to make this a Python file, and we have to name it like python-help.py. So what that will do is move that file to that location. Now, this is pretty useful because not only can you move it in the local folder, but you can also move it to other folders outside. So we move python.help.py, python.help.py to, let's say we want to move it 2 folders up and then call it something else. So we can do slash slash, and now you'll notice we're in my home directory, and then we can call this like I'm home.py, right? So we've essentially moved that file from where we are to my home directory. So we cd there and then do ls. You'll notice we have an I'm home.py. And if we were to actually look at the contents of this file, this is how I look at files very quickly, is I use a program called Vim. It's a text editor that's local. There are also other ones like Nano and I can't name the other ones off the top of my head, but Nano is a pretty easy one to use. Vim is much more complicated and requires learning an entire new key set. These are all like local file editors, so you could actually start editing everything out of this terminal as well. So you start like, in here, start adding text and such and saving that. But I wouldn't use Vim if you're a beginner. Use something like Nano or I don't remember the other one, but there's another one that Professor Controli recommends, so we can always do that. The other thing that you guys might need to do is duplicate a file. So we can do that using the copy file or the copy command. So we do copy I'm home.py, and then we want to put that back into my old directory with everything that we have done. So we go into temp/3002 help, and then we can make a new file here, and we're going to call that python.txt.
Arjun,
No, the I'm home file is still here.
Arjun,
Yes.
would another text editor be gedit? And then
yes, that's the other one I can't think off the top of my head. Yeah,
Okay.
gedit is the other one that you might want to use. I think gedit is like pretty nice to use. I don't think I have it installed because I run a pretty minimal installation of Linux. Yeah, so now if we go into that home directory or navigate back to it, or to that directory that I had for teaching, we go to temp/3002 help. Oh, Yoni, what's up?
Can you make text big again?
Yep. Cool. Sorry about that. Cool.
Thanks.
So if we go into that directory, oh, I'm on the wrong terminal. Yeah, okay. Here, and you'll notice that python.txt file is back. Cool. That's the basics of navigating a terminal and doing most terminal stuff you need. The other really big useful thing is if you don't know how a command is run or you don't know what options are passed in, Linux has really great inbuilt documentation. And there's 2 ways generally to figure it out. Most commands, if you try typing it and type -h or --help, it'll display like let me lower it. So this kind of will just print out to your terminal everything that you might need to know about it. So this tells you all about that command, how to use it, what arguments you can pass in. Very useful. The other one is you can view the man page for it or the manual. So most commands have a man page. And when you type man ls, it gives you this entire man page that you can then like scroll through, read through, and it'll tell you about the command. It's quite useful. You can do this for almost any command. So let's say we want to man and learn about the copy command. You can look at all of the things that you have. You can see like there's a -r, copy recursive directories, stuff like that. It's pretty useful. I highly recommend if you don't know how to use a command, man pages are just the best thing for figuring out exactly what things you should need to be doing. The other options, of course, are -h or --help. I think standard in Linux for a command is if it's a single letter parameter, you're going to see a single dash. But if it's a full word, then you're going to see a double. Or more specifically, if it's a full word with like parameters that you can pass in and stuff, these are options. Anyway, that's the basics of terminal navigation that I'll go over. Are there any real questions on how to use a terminal like that?
Yeah, I got one. Initially, you used like a $PWD thing where you wrote PWD. What does that do?
PWD lists the path to the current directory. So if I type PWD, it'll print out here /home/origin/temp/3002 help. So let's say you were somewhere and you need to know, how do I get back to this file, or what's the exact location of this file? You can type PWD and it'll tell you what the folder is. PWD is really useful for piping into other commands. It's something a little bit more advanced that you guys might have seen. If you ever see somebody do PWD and they're like pipe, what that does is it pipes the output into like another command. If you want to know more about it, Google it. There's a really great textbook called How Linux Works, I believe, that goes over exactly how to use Linux and goes through like all of this in detail. I highly recommend giving that a read if you really want to become like a Linux expert overnight. That thing covers everything from like what the basic commands are to navigating your terminal to like in-depth kernel stuff. And so it's a great textbook. I'll link to it. It's like 40 or 50 bucks to get an actual textbook, but it's a really great resource that I use. Okay, that's the basics of terminal. Anything else? Nope. Okay, cool. Let's talk about Python because that's always this is the fun stuff. Okay. So the language we are working in is going to be called Python. You'll notice on my screen I have these little parentheses called 3002-help. Don't worry about that right now. But that's a virtual environment that I'm making, which is a thing that's like a couple Python packages can do. It essentially allows me to isolate Python environments from each other. Since I do a lot of work where I need to switch between versions of Python and such, I try to keep them all separate because the package numbers can get messy. But in your guys' case, you should only have Python 2 installed on your thing. So I won't worry too much about it. But if you ever want to check what version of Python you have in your terminal, you just type Python -- version. And that'll print it out. You can see I'm running Python 2.7.18, which I think is one of the acceptable versions. I think you need to run over 2.7.16 for the class. So we're going to work out of here. So let's talk a little bit about how Python works compared to other languages and kind of get an idea of what's different about it and what makes it special and the little quirks you need to keep in mind. The biggest thing, Python is not a compiled language. So unlike C or Java, where you can write your code and then in like any order, basically, it'll compile it, it'll read it all, it'll figure it out for you. Python does not do that. So when we're writing a Python file, let's just make a new Python file. Here, the code we write. So I'm going to use VS Code to edit Python files. You guys can use whatever text editor you want. It's really no big deal. Nobody cares. Python doesn't care. There's a couple things about how you edit it and spacing because Python cares about white space, but we'll get into that in a second. Basically, if we have Python code where we do like 1 + 1, like x is equal to 1 + 1, and then we have y is equal to 2 + 2, Python will execute these things in order. So if we do then y is equal to, so essentially the order that you write commands is the order it's run. This is really important for function definitions if you're doing a single Python file, because if you do not put the function above where you called the function, Python will not know that that function exists because it executes it line by line. And we can see a really good example of working this if we open up the interactive Python terminal, which is a really useful tool if you just want to play around and run some like Python code, but you don't want to have to like save into a file or do all that work. You can just type the word Python in your terminal and it opens up a little terminal inside, or which you can now run Python specific commands. So for example, let's say we wanted to print hello, like a string that says hello. You can essentially run Python code here line by line. And because of the way Python is run, it will like read these things in order and execute them in order. So we can do like x is equal to 1, and then we can do y is equal to 2, and then we can do x plus y equals 3, or we do x plus y, and then we can get 3 as our output. Python is run in order. Keep this in mind when you write code. There's a couple tricks you can do to get around this. You could define a main function at the top of your code, because if you want to, code style, keep your code at the top, you can do that. Or if you're doing classes, it's a little bit different, but still order is important there. But we'll cover that in a second. So this is an interactive Python terminal. You can just run Python code here willy-nilly. You can just do anything that you would do in your Python code, you can do right here. It's a really useful tool for just testing stuff out very fast. To exit this, you can either type the exit command like this, or hit Control D on your keyboard, and then you'll exit back out into your normal terminal. So let's talk about the first and basic thing in Python, data types. What data types do we have? How do they work? And what can we do with them? So the biggest thing one of the other really big things you can keep in mind is everything in Python is an object, right? We don't have like your base data types are also objects. Like this, when we make an integer, like x is equal to, let's say 1, x is an object. Even if the object is of type int, it is not a like base data type, it is an object, which means you can do anything you would do to any other object to it. And this will come up in a second, but the way you check what an object is in Python, or what type of object is, you can use the type command in Python. So if you do type of x, we will then have it print out whatever that is. So let's do this, and then let's print the output of that. and see what it does. Running Python files. To run a Python file in your terminal, you type the word Python and then the name of the file. Hit enter. It will then print out or do whatever is in that Python file. That's the easy way to run it. In ROS, it'll be a little different. In ROS, we need to put that into our cmake.txt and have it compile and read properly and stuff like that. But that you guys should have covered with the ROS tutorial / will cover with the ROS tutorials if you haven't got there yet. So let me do one other thing while I am here, and let me go grab the homework so we can go over and make sure I cover everything on there because that's important for you guys. Dun, dun, dun.
Is there a way to run it just in the Python editor?
So some editors have that. I can also do it here. So if I do control Shift P and then I do terminal, I think if I type terminal, yeah, I can open a new external terminal.
Okay, so I see a run button at the top of your thing. That's why I was.
I guess it does do that. Okay, it tries to run it, but it didn't open the right environment, which is a special thing about platform. So the run button is Platformio, not stuff here. So what this tried to do was run this in Python 3, not in Python 2. That's just because of the way I'm doing it. If you were to hit the run button, I guess VS Code will handle it. I think it has a Python package built in, but in general, learning how to run it from your command line is very useful. And so, yes, there are ways to run it. If you look at your editor, I'm sure your editor has like plenty of tools to help you run it in terminal and run it in place. But we're going to use the terminal because that's what you guys should get familiar with. Okay, let's look at the homework one and have this open on the side. Boom, boom, boom. Save, open, cool. Okay. So let's talk about data types now. So this is a type. If you actually look back at the terminal, you'll see how it said type int. Int is a data type. String is a data type. Lists are a data type. All of these are objects. They are not like native data types like Java is. And so they are stored differently and they are treated like objects, which means in Python, we can do stuff like this. Because they're objects and Python is smart, it will figure out what type of object it is for you. So we can do something like this, where we set a previous thing that was set to an int to a string, and Python will not care. Python will just do. Run that file again, you see now it outputs a type of string, or of type str, which is string in Python. The other really important thing to remember, you cannot use these names. You cannot name a variable str, because what happens is you name a variable str and then type it. Actually, I don't know if this will let me do it or not, but we'll see. Let's say we try to name a variable str and run Python NumPy. And then we'll print. You'll see what happens if we try to, if you overwrite this name here or these object names, Python will just overwrite the object definition out of itself. So do not use int, do not use list, do not use tuple, do not use string str as a variable name. You will just mess up Python internally and then not be able to do like half your string functions. Or I think technically str is a function, so it'll overwrite the str function, which you don't want to do. So be very careful when you use names. Make sure that you're not overwriting something internally in Python. It won't yell at you. It won't tell you. It'll just overwrite it. So there's not really a lot of inbuilt protection. Essentially, if you're an idiot with Python, Python will let you be an idiot. So the other thing I want to move back onto is I don't need this anymore. So let's go through our different data types. Int. All numbers are stored as an int. We have ints are, I don't know what the max range of int is, but I know it's like equivalent to essentially like a long in Java. You'll probably never, or maybe even larger, you'll never hit the end of it. So all numbers are an int and they're just numbers. Strings or strs. STRs are string types. They are strings. You store them with either single or double quotes. Both are acceptable in Python. So if I were to do this versus the single quote, both are acceptable. Both will work, and you should be good to go. So let's write a very simple program to take two numbers and add them together. Actually, let's write this in a function. So in order to define a function in Python, we use the def word. So we do def, and then we write our name. So we're going to call this add num, and then you write parentheses, and then you put in your variables in here. So we're going to do x, comma, y. And then to finish this off, you do a colon. So that colon now means that we start a new block. Notice how my editor automatically put me over 4 spaces. PEP 8 convention says that you will use 4 spaces in your Python code. Double check that your editor will convert a tab into 4 spaces. If you do not use 4 spaces, the spacing of your code will be off and you will be very sad. Okay, so essentially every time anything that would require an indent, which is either function definitions, if statements, anything that ends with a colon then means indent, and indent means 4 spaces. Because Python does not like have parentheses, so we don't lock off code with parentheses, we lock them off by their indentation level. So if we do define 2 numbers and we have this return x plus y, and then we wanted to run that code, if we were to write code here, it would be part of that statement. But if we backspace and then do add underscore num 3, 5, it will then run this code as soon as it like starts. Python essentially goes through and at the start of the code will execute the first line, the second line, the third line, the fourth line. And if it goes into a function, it will then read that function, store that function name, and then come back out of it and run the next line. So what you have here in this code, when you run this Python file, just run these code lines in order. There's no like compiler, there's no executable, there's no like run this function when I call you. It just runs. In order to display it on the screen, we're just going to use print. In Python 2, we use a space and then the function you want to print. You can also print multiple things in a line if you do like the first variable, then the second variable. So we just do like a 5 there or some other variable there. That'll also work. In Python 3, there are parentheses around it, and that is acceptable. In Python 2, do not use the parentheses. It will do something else. It will then like define a tuple and do weird things. So Python, it is just print and then the values you want to check out there. Cool. Let's run this code and see what our simple function does. So we run test.py again, and you'll see it prints out 8. Where am I? Okay, cool. So that's the basics of some function definitions, some print statements, a little bit of int manipulation. Are there any real questions there? Did I cover anything that doesn't make sense about how to do these basic number types? Yes, no. People are good? Okay, let's move on then. So the next thing I want to cover is lists in Python. Lists in Python are pretty cool. You can shove anything into it. Lists in Python are very dynamic. They're not like Java, where Java has rules and you have to define what the list will be, you have to define what the length will be. Python doesn't care. Python will just do. So a list in Python is defined in one of 2 ways. So let's call our variable L, which is defined a list. You can either define it by doing an open bracket and a close bracket, and then putting your object inside. So let's say we want to have a list of 10-ish numbers. We do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we have a list of 10 numbers here. This is one way to define a list. The other way to define a list is by using the list operator. So we can also do L2 is going to be equal to list, and then we can pass in some variables here, right? So we can pass in any number of variables into this, and this will also work, right? So we can do some list of, we'll do like a list of characters or something. We can do like a list of strings, A, B, comma, C, comma, D. Okay, both of these are acceptable ways to define a list. In order to view what they are, we use a print statement. We're going to print L, no bad, print L, and we're going to print L2. Cool. Let's see if I got that right. Oh, just kidding. I lied. List, that's a different list function. That's not a thing in this version of Python. Ignore this. I said nothing. This is not a thing. That will come into play just later. Okay, this is how you define a list if you have numbers. We'll go over changing and manipulating things into lists in a second. So we run this code again without the error. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's a list. The other question is, how do I convert something into a list, right? Python will just take, that's what this list operator is for. If you do list here, what Python will do is take the thing that you pass into this function and attempt to turn it into a list no matter what. So if we print out L2, let's try passing something in. That would be fun. If we pass in a string, we're going to call this hello. Let's see what Python does to it. Python will take a string and force it into a list. it will try really hard to. So the Python functions don't really tell you what they can and cannot do. They will just start running stuff for you. So you got to be very careful and know what the output of your function is probably going to be, because sometimes you get some unintended behavior. In this case, what Python did, the native behavior of Python is to take the string object and split it up by character and then return to you that list of characters. So it turns this into a list of characters, which is very useful in a lot of your code. So keep that in mind when you're running code, that you can just use these things. You can also try doing stuff like this, where you're like, okay, let's say I wanted to turn hello into an int. It probably won't let me. We're going to call this I. But you can do the same thing with ints here. So you can do int and then say, I want to turn hello into an int. And if we run the code, it'll yell at you saying, you cannot have a base 10 hello. But if this was a string with a value of 200, check this out now. L2 is not defined. I'm smart. Hold up. There we go. It'll just do it. So Python will do it when you pass something into these Python functions that are native to Python. There's a lot of code there to try figuring out what they think you mean and doing it for you. So generally, you need to make sure you kind of understand the expected behavior or play around with it to figure out what the expected behavior does, or what that function does. So let's say we wanted to go back. Let's say we had this list here and we wanted to convert it into a string, just like we did before. If we type str and pass in the list object as a whole, well, actually, use the variable that we made. So we'll call this, we'll just pass in L. What will happen is we'll get this, but it's a string now, right? Am I correct? If I do type, let me check. Let me see, did I do this right? Did I not save? Yep, it prints out a string, even though it came out looking like a list. It just converted that list and shoved it into a string format, even though that was like, so you see how it's doing a little weird stuff? You got to keep in mind what's happening here and what this function is expected to do. Keep this in mind when you're playing with Python. The best way to learn these things, being honest with you, is just sit down and play with them, or like Google what the expected function is. Like if you Google that Python definition of like the Python definition for Python 2 of str, it'll like give you an explanation of what it returns in the different scenarios that you pass in. What these functions are actually doing is every class in Python, when you define an object, has these inbuilt functions that you can optionally define / Python defines. And these functions call some of those inbuilt functions in there. There's like a toString function in every object. And that determines what the behavior of that object is when you type str on it. Okay, so back to list. Let's talk about now iteration. And actually, let's talk about if statements first, and then we'll go into iteration. So let's define a string. We're going to call this string, call him S, and he's going to have the word hello in it. Okay. And let's define two numbers with we're just going to call this n1 is going to be equal to 5, and then n2 is going to be equal to 7. Cool. There's a 0 in that hello. Okay. So now we have two numbers and a string. Let's first of all learn about basic if statements. So in Python, if statements are defined with if, and then we're going to do if n2 is greater than n1. Yoni, what's up?
Can you make it bigger again? My blind.
Okay, cool. Did that help?
Yeah, thanks.
Cool. Yeah, let me know if it's too small and you can't read. Anyway, so we have if n2 is greater than n1, we want to print n2. And then if we want to do an else, we do else, colon, and then we do print n1. So if we run this code, what we should see is just n2. We switch around these variables. We should get, make that smaller. You should get n1. Pretty basic stuff with if statements. There's a lot of really cool things we can do though. Let's say, so you're familiar with this idea of greater than, equal to, equal to, not equal to, right? So those things make sense. But so what these operators do, compare the value of these objects. But we have another type of comparison in Python, and these compare the actual object itself. So let's do a case here where we say 6 and 6. If we do this, what Python will do is say, is the value of n2 equal to the value of n1, which in this case it is. However, we have another operator, and you'll see this a lot. It's called the is operator. Now, what that is doing is comparing the actual objects themselves, which is different. So if we now run this code, just kidding, that worked. I'm an idiot. Why did that work? Did I save? Just kidding. That demo completely failed, and I'm an idiot. Oops. Okay. Is compares the object themselves. I don't know why that case is working, and I will figure it out and let you know in a second. But
because N1 and N2 are both 6.
Yeah. So the thing is, I thought it would compare a different object type. I thought N2 and N1 are different objects in Python's code. Give me a second. It's generally used in cases like this. So if you were to do like type N1 and type N2, then you're comparing like the return objects for these are both the same like int definition. So then you would get an R equal. But I'm not sure why that case is working. I think it might have something to do with the way ints in Python 2 are handled, potentially. This might be some weirdness with Python 2 being special. Anyway, is used for comparing objects. Equal is used for comparing values. So just keep that in mind. The other time, oh, you know, it also might be a number thing. If we do 2 strings, hold up, let's see this. Does this also work? I'm wondering now. We're learning together. Is this one? Just kidding. Yeah. Okay. It works with the basic data types. It might not be the same in other cases. But anyway, this use is and not. The other one is not. So we have a not operator that checks if 2 things are not equal, which you do is not. You'll get not the same. So not and not are used for comparing types of objects. And once I figure out a demo for that explains the difference between the two. Actually, you know, we can learn this together. Hold up. Between is and equal. Python 2. Okay. You're gonna have to add Python 2 to all of your values. Okay, here we go. The demo was with, I'm smart. Okay. The equal operator compares the values of both operands and checks for value quality, where the is checks whether it refers to the same object or not. Okay, so what's happening is because Python, the way Python works is when I define 6, it defined these 2 6s as the same thing. They refer to the same place in memory. So they're essentially the equivalent. A better way to demonstrate this, I think, is with the list itself. Yeah, okay. Okay, yep, so let's do this. So let's define this with list because lists actually do a much better job. So what's happening is Python, when it defines 6, points to a place in memory where the value of 6 is stored. And so what's happening is both of those 6s point to the same place, therefore they are the same, according to Python. So let's make a new list called L1. Let's make a new list called L2, and then let's make a new one called L3. And because lists are these more dynamically defined things, they do not all point to the same place in memory, even though they're all equivalent. So now if we do L1 is L2, we should get not the same. Yeah, cool. Okay, this makes sense now. Okay, and then we'll make L3 equal to L1. Perfect. So what's happening is Python is trying to compare whether these 2 objects are the same object, and they are not because they're 2 different lists. And so we get not the same. However, if we make this an equal, and then try running the same comparison, we'll notice they are equal because internally, and they look the same and they have the same values inside of them. So again, is and not are for comparing objects. Meanwhile, equal is comparing values. Checks values and checks for equality. Does that make sense to people? I know that was a little bit confusing because I messed up, but that's a very important distinction to understand when you're running Python code. Cool. If that makes sense to people, we will move on to the next thing I had, which is lists. Okay. So now we know how to do if statements. Let's back a couple lines of code here when we go to the part where I had a list defined. There we go. Okay. let's iterate through this list. Let's talk about iteration. So in Python, there is no for, there's like, you know, in Java, how we have like for I is equal to 1, I is less than 10, I plus plus. That's a lot of effort. We don't do that here. In Python, we do for in loops a lot. So we do for, let's say we wanted to iterate over every number in L. We do for n in L. And what that does is it iterates over every number inside or everything in the list. So then we'll just have this print out L or print out n. Cool. Let's run that. You'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's the other fun thing about list in Python. You know how all of these are ints? You know, in Java, you'll be like, I wanted a list of ints, and only ints can go into this list. In Python, we can put anything in here. Let's say we want a list that says hello. Python doesn't care. Python will just put that word in there. The objects inside a list do not have to be the same object or same type of object, which makes this very powerful and also terrifying, because you can just shove whatever in there and Python will not stop you. Right? So now let's do a thing where if this is a number, we want to add 2 to it and then save that back to L. So, or just and print that out. So we do print if type of n. So we're taking the object there, and then we want to say if that is an int, right, which is an object we're referring to, and that's what that will return. Then we want to print n plus 1, and then else just print out n and don't do anything to it. Cool. And make sure you put your colons because those are important. Cool. You'll notice how now we added 2 to everything except for hello, and we were able to filter it out essentially. So let's say we wanted to iterate over everything here. Let's make this back into a number for simplicity's sake. And we wanted to add 2 to each one and then save it back into the same thing. Well, we can't actually, so if we were to try doing that, and let's say we wanted to just say n is equal to n, or we'll use the plus equal operator here. So in Python, you can either do n is equal to n plus 2, or the lazy way of writing it is n plus equals 2, which will take the object and then add something else to it. Oh, I need to print L. Don't parentheses, Python 2. Cool. You'll notice how it didn't change the list, and that's because we never re-updated the object in there. So there's a couple ways to handle this. The way we need to handle it is we actually need to get that index value from Python. So we can do this as the following. We do for n, or for I, in range, and then the length of L. So what does the length function do? The length function will take in any object that you shove in, whether it's a string, a list, stuff like that, and try to figure out how long it is. So I think the length object can take in lists, you can take in strings, and it'll just process it and handle it. Now, because we're no longer getting n, we need to get n. So n is going to be equal to L. Oh, I didn't talk about how to access list objects. Let's talk about that now. In order to access objects in a list, we'll comment this out really briefly. Comments in Python, by the way, are a pound sign. That's what we use. All right, let's say you want to get an element out of a list. What are the ways we can do that? So let's print out whatever we get. So we print, and then let's write some code. Okay, let's say we wanted to get the first object in a list. You do brackets, and then you type in the index of the object you want. So let's say you want to get the first object. Python starts at 0. We're not in MATLAB anymore, and we're not using a stupid programming language. No more indexing at 0. We'll get the first object out. Let's say we wanted to get the last object out. So you can do L2, we get the third object, or yeah, stuff like that. Really easy. Let's say we want to get the last object out. We can use -1. So now if we run this, we'll get the last object in our list, no matter what it is. So you can now essentially count. You can also index forward and index backwards. -5, we'll get 6 out. So essentially we've counted -1, -2, -3, -4, -5, and then we get that object. That's pretty useful stuff. The other thing we can do in Python is also pull out ranges. So let's say we wanted to get everything but the first object. We can do 1. Actually, let's say we want to get like the 3rd to the 5th object. So we do 2:6. There we go. And then we'll get 3, 4, 5, and 6. I meant fifth. Yeah, there we go. Sorry. We get 2, 3, 4, and 5. Does that make sense? What we can do there? We can positive indexes, negative indexes, and then ranges like this. The other thing Python can do is if we backspace one of these and just do blank colon 5, it will get everything from the start to the fifth element. So we can do something like this, and we'll get 1, 2, 3, 4, and 5. The same thing also works in the other direction. So if we want to get everything to the fifth element onwards, we'll get 6, 7, 8, 9, 10. Those are pretty simple. I'm assuming you guys understand how list indexes work. They work the same in Python. Like this, they were technically referring to the index before each of the objects in the list. Cool. Any questions about accessing lists?
What about if it was like in the homework where they have the north and then like how would I address something like that?
We're going to get into that in a second when I get to tuples.
Okay.
But essentially, or another way, just explain it. You can put another list inside of here, right? Nothing is stopping you. Remember, you can put objects inside of objects, so you can just nest lists infinitely deep. It's not a problem. That's why that works. You can just shove whatever object you want in there, which means people can like really mess with your code and your inputs. So you have to actually like really sanitize them. Anyway, let's do this example, and then we'll go over what tuples are, and then we will actually try like kind of roughly going over the homework problem together. I think those are good examples. L2. So we do L, an index of I. So range, what we'll do is actually return an iterable object. And then for that iterable object, it will be a list of all of the indexes in list. So it essentially gives you a value from the range function. Functions like, okay, let me back up a step and explain what range does. Range will take, if you print out what range gives you, so we're going to turn whatever range gives us into a list, and we're going to type range from, let's say we wanted to range to 10. Let me comment this out again. Range will essentially do exactly what it sounds like, which is essentially like linearly interpolate or by like indexes. So we do Python test pi. We'll get a list from 0 to 9. That is that. You can also pass in a starting point. So let's say we want 4 to 10. You can run it like that. You can also pass in a direction or like a step count. So we can do 2. So now we want to count from 4 to 10 by 2s, and we'll get 4, 6, and 8. It's a pretty useful function to just generate out index lists really, really fast. So that's how the range function works. And if we get back here, now you know what I is in this case. So now you do for I in range of length L, and is equal to this. Then we do L bracket I. So now we're resetting the value inside that. It's going to be equal to n plus 2. Cool. Now, if we run this, we're going to list output where everything is incremented by 2. Cool. That's the basics of lists. There's a lot more that you can do. There's a lot more fun stuff. You can append stuff to lists using l.append and just add, like an extra value there. So now if we run this, you'll notice there's a 5 at the end because it did this and did this. You can l.pop. So if you do l.pop, it will take out whatever index you pass in. So it's going to pop out the third index from here. Let's actually just move this print L up here. I'm trying to think of stuff that'll be useful for A star specifically. You'll notice it'll pop out whatever index is there. The other way, instead of pop will actually return the object. So you can then like save this as like X, right? So if you want to actually pop it and then get that value back, you'll like get that. If we then print X here, you'll see what that value is. It'll pop out the 4. However, if you wanted to just delete it and you don't actually care about it returning anything, or you don't want it to return anything, both are valid options. You can also do del L and then the index you want to delete. So we can do like L3 or something, and it'll just delete that object out of existence. This is also a fun one, but be careful with this because it'll just, wipe things. It's quite scary. Okay. Those are lists. We have another data type in Python that's very similar to lists called tuples. The difference between a list and a tuple is you put round brackets instead of curly brackets. So while lists, the data types in lists are mutable. You can like change them and move them around. The data types in tuples are immutable. You cannot append to it. You cannot change what's inside of it. You can overwrite them, but you cannot change them, which is very weird. So if we try to do L.append here, now that this is a tuple, we append to value 5, we'll get an error. Tuple has no object attribute append. You cannot add or change things to tuples, which is why you generally use them for like, they're great for pixel coordinates where you don't want to change the values after you set it the first time, stuff like that. So that's a tuple. You can convert between list and tuple using the tuple and then passing in L, or, you know, in this case, we can go like from a tuple to a list and call it. Essentially, that's the really big key difference between them. There's a couple other subtleties that like don't super matter, but could become problematic. If you're ever confused why stuff is acting weird, just make sure you understand the difference between list and tuples. So in this case, let's take this list right here and figure out how to parse it to kind of help out with the first question of the homework. So we're going to get our directions. We're going to call this dir. We're going to have it's a list of tuples here. So the first question is, how do I iterate through my list? Well, we do a for, we'll call this like dir pair or something. It doesn't matter, it's just a variable in dir. Wait, I shouldn't use dir. Actually, dir is a native thing in Python. Direct instructions. Spelling is hard. Okay, for instructions in dir pair, we're going to then print out my direction pair. And then what we should see. Oh, they're not ASCII. God damn it. Okay. Since I copy and pasted, I copy and pasted non-standard characters into this. And so now it's yelling at me. Don't copy and paste code unless it's an ASCII. Not gonna work. Yeah, okay, cool. It was just a quotes. So now we get a list of our tuples that we can iterate through. You can access things in tuples the same way you access them in lists. So if we print out print dir underscore pair, we can print out dir pair 1, which is going to be, we should get 2, 3, 4, 5, 1. Or if we do dir pair 0, we'll get north, south, east, west, and south. They're pretty useful. I highly recommend them for anything that you don't think should like change in length ever, even by accident. That's when you use a tuple. Cool. Does that make sense? Any questions so far? Cool.
So they said in the homework it can go in any order. Is there a way to change the order of that list so it's always our code can read it in the correct order, so we know north is always first?
Oh, what do you mean? So you know north is always first?
Like in the array, the north will always be the first item, so that you get what I mean.
Why does that matter?
Because it says in the code they can be put in any order.
Yeah.
Okay,
Does it matter though?
I guess not.
Right, like your code shouldn't care. And also, I can also give you any length. So why would you want it to go north first?
Do they have positions within the tuple? Like,
Yes.
is N2 a position within the tuple?
N2 is a position in the tuple? What do you mean?
So can you like say select element 1 in the tuple and then it will print out?
Yep, if we do dir pair and then the same way you access the list, you access the tuple. It's the same thing. So you get north, south, east, north. Let me make this bigger. You get north, east, south, and west, which is north, east, south, and west.
You said two things that sort of confused me. So you said that the tuple you can't change. Does that mean you can't change the value of any of the elements in the tuple, or does that mean the length of the tuple?
It's kind of weird. You cannot change the length of the tuple. I think you can actually overwrite the value of a tuple. Let's check actually. Let's find out.
You said you could overwrite values. So is it just creating a new one and changing?
Well, so let's see. 1 second. If I make a tuple here called T and just say that's a tuple of 1, 2, 3, 4, 5. I don't remember if this works or not, and I just need to double check. So if we do T1 is equal to 6. Yep. Okay. You cannot reassign single items inside the tuple, but you can overwrite the tuple as a whole. So I can't change what like T1 is, which is 2. I can't make 2 6. It will just yell at me. However, I can change T to 6 and that will work. So once you define the tuple is locked in. Unless you overwrite the entire tuple as a whole. So if I make if I make T and I said T is equal to this tuple, right? and then I wanted to change the value of the tuple, I would have to rewrite the entire tuple. Right, and that would work. But if I were to try changing an individual value of the tuple, it would then yell at me. Make sense?
Yeah.
Cool. Tuples are essentially like locking in the contents. I never want to change these again. They're really, really useful for just making sure your code doesn't do dumb things. Such other people can't do dumb things with your code, which is the more important case. Cool. Let's talk about dictionaries. My favorite data type. Okay, dictionaries are a very special data type in Python. They are like JSON files, but in Python, and they're wonderful, and you can do so much with them. And they're the best. You can do a bunch of stuff. So how do you define a dict? You define a dict with the curly braces. So you do curly braces like this, and dicts are not just lists, they are key value pairs. They are a list of key value pairs. So you have to have a key, which must be a string. So we're going to do key high, and its value, which can be anything. It can be a number. So we can define it like this, and then you put a comma. You can do stuff like that. So this is a dictionary. Essentially, you have a list of key value pairs, and you can access things by the keys. So instead of in list how we have to figure out what the index was, you could then do dictionary and then pass in the key value. So like high, and then we'll get the output. So let's print this. Oh, exit. Okay, cool. And you'll see it printed out the value of high. We're gonna change this to hello. You can store anything in these values, including other lists or other dictionaries. It does not matter, but they're very powerful. You can also iterate over dictionaries. So if we do for, so here's the thing. If we were to try doing something like this, so we do for I in D, what would you guys expect to happen? Most people used to, I was gonna get like high and 4. Well, the thing is, it doesn't really work that way, because the thing is, when you say for I and D, Python lets you go, this isn't a list. I can't make this into a list. How do I make this into something I can iterate over? So dictionary has 2 built-in functions. If you want to iterate over the keys, we can do d.keys. It's a function. And then we can print out I. So let's do that. Print I. What? Dict object has no S. Oh, keys. There's an S. I'm smart. Okay, sorry. Hi and hello. Or you can do d.values, which will get all of the save. Did I close the file? I'm smart. Okay. d.values, which will give you all the values in a dictionary. So you get 4 and our list there. You can also do d.items, and what that will do is return a tuple of key value pairs. So key value in a tuple format. Or you can do an even cleverer thing. You can unpack the tuple live in the for loop by doing I, comma, so we can do k, comma, v. And now we can print out k, and then we can print out v. So now when you do that, you'll get high 4, high 4. So essentially what that does is it puts the key in k and v in the second thing. So essentially unpacks that tuple for you. I covered a lot there really fast. Does all of that make sense?
You went too fast and the definitions weren't clear, so I forgot them all.
Yeah, can you go through it one more time slower?
Yeah, let's go over it. Let's go over it slower. Sorry.
You could them in like 6 seconds.
Yep. Okay. So we understand that tuples or dictionaries are key value pairs. That make sense?
Yes.
Okay.
Go over what keys does, and then go over what values does, and then go over what items does.
Okay. So if we wanted to iterate over the keys in a dictionary, we do you got for loop for in d.keys. So we got that, and then we just print out our I value. So what this will do is take our keys in our dictionary, turn them into a list. So if we actually, let's do this even better. Let's just print out what d.keys does. See how it returns a list of hi and hello? So essentially, d.keys returns a list of all of the keys in the top level of our dictionary. We can also do the same thing with the values. So if we do d.values, we get 4 and 1, 2, 3. Now, if we do d dot items, we get a tuple. We get a list of tuples. So just like your north-south, actually, yeah, just like your north, where is it? Just like this tuple here, array of tuples, we have a north-south, yeah. So just like this thing, right? Where is it? Why am I blind? Oh yeah. So just like this thing right here is a list of keys. It's a list of tuples, and the tuple is a key value pair, right? Where the first item is a key and the second thing is a value. So those are what those three functions does. Does that make sense?
You went a little fast for me. So what does values do? I'm sorry.
Values gives you all of the items. So values gives you all of the values. So it gives you like 4, then it will give
So
you
it
this
gives
value
you,
in a
it
list.
gives you the other side. So it doesn't give you the keys. It gives you the other side of them. So
Yep.
values and growth.
Yeah, so these are called key value pairs, right? So this is the key, this is the value of the key.
Items does.
That makes sense?
And then what does items do?
Items gives you a tuple, a list of tuples with both the key and the value in it. So notice how the first thing is our key, the second thing is our value. The next tuple, the first thing is our key, the second thing is our value. We can even, let's make a dictionary that represents our homework, actually. So if we do north, what are those values? North 2 and 2, east 4, I think it's then south 1, and then west 3. Cool. Right. So now if we print this out, we'll get the actual tuple that he gave you just in a different order. So the other really big thing is order is not preserved in dictionaries because they're key value pairs, not lists. So the order which Python stores these in will be changed around and shuffled. You cannot rely on that, which is an important thing to keep in mind. So don't expect north, south, east, and west to stay in order in your tuple. So you never try to rely on the key value pairs being in a certain order because that will just break your code. Okay. Is that clear on everyone? Everyone understand what's going on there? You can then iterate over things using for loops. So if you do for I in d dot keys, items, or values, all of this will work. And then you can print out I, right? So now this will now print out every key. So you get south, east, west, and north. Or if we do d dot values, we'll get 1, 4, 2, 3, and 2. Or if we do items, we'll get a list of tuples. That'll output south, east, west, and north. Cool. That makes sense? I'll take the silence as a yes. There's some other cool things we can do with Python. One of the functions we can do is something called unpacking lists. So let's say you had a list here, we'll call this L is going to be equal to just, or unpacking a tuple list, same thing, right? So we do unpacking this tuple. And if we do I, comma, j, comma, k is going to be equal to star, star, and then L. What that does is it takes the tuple, takes the 3 values out, and then passes them into I, j, and k respectively, or the number of values in the tuple. If we run that, it's not star. Oh, it's single star. Sorry. That unpack. Just kidding. Is this not a thing in Python too? It is. Oh, my bad. It doesn't run just natively like this. You have to run it inside a function. So I'll demonstrate that in a better place. How about we do for I in d dot values, right? So let's say we wanted to automatically unpack keys and values, and we have to so there's 2 ways to do this, right? We have I, and then we want to do k is going to be equal to I0, and then we have value is going to be equal to I1 because we're getting a tuple back, and then we want it to print. We're going to print print k comma v. Okay. Smart. Okay. Make sure you put parentheses. Okay. Int object has no. I forgot. I used the wrong method. There we go. Okay. So we have I, and what we're doing is like saying the first value is going to be our key, the second value is going to be our value. Python can do this for you by unpacking them. So if we just do k comma v, it will assign the first value in our tuple to k, the second value to v. And then if we run that, we get the same thing.
Can you go back to the output? You went very quick. I want to see what it.
Yep. Here you go. So you see the first thing we have is our key, second thing is value. First thing is key, second thing is value.
And that's taking it from the dictionary.
Yeah, so what that's doing is taking, well, so this is returning a list of tuples. And then this comma that you're putting there is essentially taking that tuple, splitting it up into its parts, and then assigning them to each of the variables.
So in theory, we could use this to know that north and then add 2 to north and then subtract 1 for south and all that, you're saying?
Mm-hmm.
Because now we've split it apart.
Yeah, you could also do a bunch of, you could do a bunch of cool stuff with it. Right, so in the case that you get it, if you were to iterate through the list and then do k comma v for I, it would also split it apart. Okay, there's a bunch of other stuff I want to go over that I don't think I have written down, but we'll go over in a second. Yeah, so this is just the basics of, these are most of the common data types. This is just about everything you will run into. Let's go over to like 2 or 3 fun things that we can do in Python that save you a lot of writing, because writing code is effort. Let's say we had a list. The list had 10 numbers in it, or 5 numbers in it because typing is effort. All right. And I wanted to add 2, just like we did before, but typing is a lot of effort, and I want to save that as a new list. So we're gonna call this L2. So we could do that whole for loop that we typed out, where we sat down, wrote the for loop, did the range thing, put a number in range, stuff like that. Or we could use a thing called a list comprehension. And these are where Python gets like kind of stupid, that you can just single line this entire function. So list comprehension is written as following: variable for variable in list. Okay. What do you think this is doing? Anyone want to take a guess? Or I'll explain it to you. How about that? Okay. This is going to run a for loop for every x that is in L. So 1, 2, 3, 4, and 5. And then apply whatever function is here. So you can do something like x plus 2. You could write your own function, do custom underscore function, and then like put x in there. All sorts of like stuff you can do with this. And then it takes that entire output and turns that into a new list and saves that as L2. So we're going to print L, and then we're going to, what? That's not, oh, it apparently shift enter tries to run the code. I would like you to go away now. Sorry. All right, we're going to print L, and we can also print L2. So that single line did that for us. Even crazier is we can filter out stuff by putting an if statement in there. So if x is greater than 2, or if x mod 2 is equal to 0. So basically, if it's even, then only add 2 and give us a list. This is incredibly powerful. You can do some really fun stuff with this. I essentially turned that entire, like, the alternative for writing all of this code would be for I in range of length L, right? So we need to find a new list called L. L3 is equal to blank. Range of length L. Then we say, no, bad. Then if, so then we set some numbers. We're going to do n is going to be equal to Li. right? So basically get that the number is going to be equal to the ith element of the list. If that number modulus 2 is equal to 0, so if it's even, then L3 dot append, and then we're going to do n plus 2. Right, so we can compress all of this code here into a single line because writing code out is effort. It's pretty powerful. I highly recommend using it. We can also do the same thing with dictionaries. So just like we have list comprehensions, we have dict comprehensions. So we can do D is going to be equal to, and instead of using those open brackets, we do curly braces. So you can do, so we can do X comma X plus 2 for X in L, right? So what this will do is it's going to make a key value pair of X and X plus 2 for, so the key is going to be X, the value is going to be X plus 2 for every X in L. Am I dumb? Our dict comprehension is not a thing. By the way, in case you're wondering how like we help you out with, oh, my bad. I think it's this actually. Yep. Yeah, okay. So we don't use a comma, we use a colon, just because dictionaries are defined by key colon value inside the dictionary. Yep. That is the thing. That it's also very powerful. You can make dictionaries like on the fly essentially out of things. Do those two things make sense? They're a little weird and a little weird to think about. Yes, no, maybe so. I will take silence as a yes. Let's go back to your homework real quick because I want to check that I covered everything in it. I think I need to cover opening files and handling files, I believe. Yeah, let's see. Dude, does he have the Word file saved on Canvas? Does anyone know?
I think he does.
Okay. Let's just write, let's write a new file. We're gonna call this, go here, we'll do touch hello story.txt and lorem ipsum generator. We take the first link and where's the, yeah, generate lorem ipsum. There we go. Cool. We'll just take this entire paragraph of Latin I can't read, even though I took it in high school, and we'll just shove it into story.py. Cool. We have this huge file with words in it. Okay. How do we deal with files? Files in Python are dealt with the open function. So we do file is going to be equal to open, and then you pass in the path to the file as a string. In this case, it's just simply test, or no, it's story.txt, right? That's what we saved it at. And what that will give you is a file object. So then if you then do want to convert that file to a string, you can do s is going to be equal to f.read, and then print out the string. So now if we run this, print this, that's not how print works, print s. Yeah, here we go. What did I do wrong? Oh, I'm just making files over. Did I delete everything in here? No, I didn't. Okay. You see, what I was running is not running the run Python command. There we go. And we will print out all of that Latin that we wrote into that file. It's pretty simple. That's how you just read everything as a string. I believe there's also a read line function, right, which will return a, let's see what this returns actually. Which reads every line of the file. If you do read line and then you do read line again, let's see what this does. S1 to f.read line. Let's see. Yep. So essentially, what that does is every time you call the read line function, you can get the next line for you. So essentially, if you do like for essentially, you keep reading the lines until read line is empty, and then you will get the entire story one by one, line by line. If you want to look up documentation, if you just look up read line Python and like read their documentation, it will tell you exactly what it does and how it works. All right, so you can also get the first 5 lines by passing in an integer. So let's say we wanted to get the first 5 lines and print out S1. Boom, boom, boom. You get the first 5 bytes. So that's a value of bytes. You get the first 5 characters out. Cool. That's the basics of file access. You can also open these in different modes. So if you want to open it in read-only mode, you use R. You can also write things to the file, but in order to do that, you need to open it in write mode, which is either a W, which will overwrite. Let's double check. Read, open file, Python options. There's a couple key options that we need to know that you should know, and they are. These are your modes. So R will open read only. RB will do read only in binary. R plus will open reading and writing. Write will open in write only mode, and this will overwrite the new file if you do it. Write plus will do reading and writing again. A will append you information. It will not delete stuff. It will also create a file if it exists. And then appending and reading is with A plus. Those are the ones you care about. There's a bunch of ABs and AB pluses and stuff like that, but those are all binary modes, and you probably won't need that. So essentially, if we wanted to write a file, we can open story.txt, and then we can do f.write and then give it a string. So we can just say hello. And if we then run this code, what will happen is it will overwrite our story.txt with the word hello. And now if we open story.txt, it just says hello. If we open this up in append mode, we can then file.write that. And now we will have hello, hello. Pretty simple stuff. Essentially, read, write, and append are the 3 modes you need to know. Questions about that? Cool. We went over function definition a bit. Let's go over how to define a class pretty quickly, right? Yeah. So classes in Python are defined with the word class. And then you give it a name. So we can call this new class. So, and then you pass in, you do a colon. All classes have, so in order to create an initializer, right? So in Java, you would generally like create a constructor. Constructors in Python are done by overriding the underscore init method of the class. So you define underscore init, and this is what Python will call when you try to make a new class object. And then you pass in whatever variables you would pass in. So we can do like X, Y, and let's just like a vector object or something. Just then I can actually give it a concrete example. Vector. So we do define underscore init. And then what this does is it's going to save a variable that we define. So if we define a variable here. Oh, actually, another really important thing. If you do, for all stuff in Python, when you write a method inside of a class, just like in MATLAB last term, where the first object must always be self. Self is a reference, just like this is. Always make sure you put self in your methods, otherwise your code will be sad. So you put in self, and then you can do self.v is going to be equal to, and then you can just make a list of x. Actually, well, let's make a tuple of x, y, z. Right now, if we want to do another function that define get vector, right, and we'll just have, or we'll just do like print vector. Print. Ooh, actually, so we'll define a print vector function. And what that will do, we'll have is just take in nothing and then print out self.v. And let's try playing with this code a bit. So let's talk about importing things in Python, because that's the thing we're going to need next. So like a new file called main.py. Let's say we wanted to use our class in main.py. So we do import and then the name of our file, but without p. So we're going to call this, we're going to rename this file and we're going to call this vector.py. And then we need to import vector. And now we can use the vector class in our main file. So we can do v is going to be equal to a new vector with a values of 3, 4, and 5. And then we can do print. So you can do v dot print vector. What did I call that? It's print. Is print underscore vector? Yeah. Sorry. Cool. And then we do that, and this should work. And we're going to run main.py. Module object is not callable. Oh. Okay, so we imported vector, but vector is the name of the file. So what we need to do is from vector, import the vector object. Or we can do from vector import star, and it'll just import all of the objects in there. But in this case, we're going to import the vector object that we defined. So essentially, we do from the file name import this. Important difference. So now, if we run this again, this should work. Print vector takes no arguments, one given. Yes, we need to pass in self to print. Always remember to pass in self. Yep, and then we print out 3, 4, 5. The other thing that we can do is we can start overwriting internal methods to Python.
You
So
go back to the Python thing that you just added
Yep.
a few times. Nope, not this.
Not this. Which
Go
one?
to this
The
one.
main.py?
Or the Py. Yeah. All right.
Questions?
So you added self to where?
I added self to, so when I defined this print vector function, I forgot to add self to it.
Okay.
Right. So remember, all methods that you define in a class need to have a reference to self because Python doesn't know to assign it automatically. Right. So I have self here, and it's always the first variable you pass in. That make sense?
Is that purposeful, or is that fixed in Python 3 where you don't no longer have to reference self?
Is that a thing?
I'm asking.
No, Python 3, you still need to reference self.
Okay. So can you go back to the other file just real quick?
Which problem? Go back.
Just, Python?
Wait, repeat where, what are you asking?
Yeah. That's easy.
Yep.
I'm good.
Cool. So we have this vector, we do print vector. That's pretty simple. But let's talk about what else we can do with this that's fun. So you know how we were like earlier doing stuff like if this and this, or like adding stuff together and stuff? Python convention states that you should overwrite the internal methods when appropriate. So when we want to print something out, we shouldn't do it like this. We shouldn't write a special print vector function like you might write in Java. We should overwrite how this vector is converted into a string. So if we overwrite the underscore underscore str underscore underscore function, when Python converts our vector into a string, we can now control how that's done. So let's make our custom string. So we can have this write a string, and we want it to be a vector. We'll like just write this little string out that takes in our thing. So we're going to do a vector. A vector with a /n, and then we wanted to have our, okay, 1 second, let me look something up. Dot format Python 2. So in Python 3, there's this really nice thing called f strings. In Python, we got to do something different. Okay, so in Python, we need to use the dot format function. So the way we do that is we would write a parenthesis sign and then either a D for a decimal, a S for a string, or here's the other stuff you might need. Essentially, or like brackets for anything else. To use these like formatting functions for string, just look up Python 2 and dot format. It's a pain in the butt, but it's how it works. So you do something, what is this thing called? A %sign D. So we'll do vector n, and then we'll do x is going to be equal to this, then another /n, and we'll copy this for y and z, And then we do, on the end of that, we do dot format, which is a function. And then we can pass in our variables in there. So we have a self.v, and then our first element is going to be our x, our second element is going to be a y, and our third element is going to be a z. And I'll show you guys what this kind of outputs in a second. I understand it's a little bit confusing probably. Cool. We have this weird string right here, and we'll come back to this in a moment. But now if we just do print and the word print v, which is our vector object, type error, return to non-string. Oh, sorry, I forgot to return s. This is important, yeah. Yep, and we get a broken thing that I did not do correctly. Did I mess up the formatting here? So Python 2 dot format 2. Oh, my bad. I'm sorry. I was referencing the wrong thing. All right. We use a curly brace and then the name of the positional argument we want to put there. So this will be the first positional argument, the second one, and the third one. All right. Yep. Okay. So let me explain this string formatting again. So what we do here is we write a string just as normal. And every time we want to add a variable that might be changing, we use these curly braces. In these curly braces, we put numbers that represent where in this dot format function that we apply at the end, that variable should be. So what this will do is you say, okay, give me the 0th input or the first input. So then it takes whatever this value of the first input is and then shoves it into that place instead of the curly braces into 0. And the same thing happens with the 1 and the same thing happens with the 2. Does that make sense what that format function is doing? Everyone gets that? All right, so we didn't do that. We can then run our main.py and we run print and the vector. We then have Python will automatically run that __str and then do that conversion for us. And this is the more correct, more Pythonic way to write classes. And you guys should, when possible, try to overwrite these __ methods. There are other things like __ add and some other things like that. And maybe I think it's like sub or add possibly. So there's a bunch of different things that tell you how Python should handle dealing with your method. Cool. Are there questions about that? If you're curious about what kind of _ internal methods there are, if you just look into the built-in functions Python 2, and it will give you a list. I'm sure like the first thing is here are all of the different built-in functions that you can then, sorry, not built-in. Class functions Python 2, yeah. Yep, so if we just scroll down in the Python documentation, you will find like all the various things that you can overwrite somewhere here. Yep, using the inheritance. Just kidding. What are these called? I think they're called built-in. Over. Give me a moment while I look up exactly what you guys need to Google so I can tell you. There are a bunch of them. My editor tells me why can I not remember these things off the top of my head? Okay, once I figure out the name, I'll make sure to send out like some sort of announcement or post on the Discord somewhere about what they're called when I can remember off the top of my head. If anybody else actually knows what they're called,
You go that real quick.
this. Okay. There are a bunch of other, basically there's a bunch of these other __ methods, which Python name I can't remember off the top of my head right now, but I will figure it out and let you guys know. But there's a bunch of them. And when possible, you should use them to you should override them if you need to. They're really useful for defining how your functions are iterated, defining how stuff is added together, et cetera, et cetera, et cetera. You can do like all sorts of fun stuff with them. I think like define like underscore add is a thing and stuff like that. So that's like the basics of Python. If you can do all of this, you guys will probably be like well beyond set for the course. Are there any questions about homework or other stuff like this? Is everyone good? Cool. If that's the case, I'm going to stop recording now. /James, can you also stop recording?